Wi-Fi, technically known as IEEE 802.11, represents one of humanity's most transformative technological achievements. Don't hold me to that statement legally, but seriously consider how remarkable this progression has been. We transitioned from physical cables and those painfully slow dial-up modems producing their iconic screeching sounds to completely invisible networks that permeate our environment. How is it even possible that with a single tap, you can endlessly scroll through social media content for literal hours? The underlying technology is actually incredibly sophisticated and fascinating once you understand the mechanics. Wi-Fi operates using radio wave transmission. Radio waves share similarities with visible light but possess fundamentally different characteristics. Unlike the light your eyes detect, which operates at extremely short wavelengths, radio waves stretch much longer and remain completely invisible to human perception. This extended wavelength property allows them to penetrate solid barriers like walls, furniture, and floors with relative ease, making them absolutely perfect for creating wireless connections between devices throughout buildings. But how exactly do these invisible waves enable you to stream videos, play online games, or video chat with people across the planet? Let me break down this complex process step by step. Everything begins when you activate Wi-Fi on your device. Your phone immediately starts scanning the surrounding area, searching for available networks broadcasting within range. That list of network names appearing on your screen represents SSIDs, which is simply technical terminology for network identifiers that routers broadcast to announce their presence. You scroll through options and select a network, perhaps something creatively named like Definitely Not a Trap or FBI Surveillance Van. Seems straightforward, right? Actually, there's significantly more happening behind the scenes than you realize. When you attempt connecting, your device and the router initiate a sophisticated handshake protocol. The router assigns your phone a unique IP address, which functions essentially as your device's specific identification within that network environment. Think of it like receiving a personalized name tag at an event, so organizers know exactly who you are and where to direct information. This identification system becomes critically important because modern networks typically host multiple devices simultaneously, sometimes dozens of phones, laptops, tablets, smart TVs, and various other connected gadgets, all competing for bandwidth and router attention. Now you're successfully connected. Let's say you decide to watch a video on a streaming platform. Your phone immediately sends a request for that specific content. This request doesn't travel as one continuous stream. Instead, it gets fragmented into numerous small pieces called data packets. These packets already exist in binary format, the fundamental language of computers, consisting entirely of ones and zeros. Your phone takes this binary information and encodes it into radio waves through a process called modulation, which involves manipulating the wave's amplitude, frequency, or phase to represent data. The encoded signal transmits to your router using a specific frequency band, most commonly either 2.4 gigahertz or 5 gigahertz. The 2.4 gigahertz band gets divided into multiple channels, typically 11 in North America or 13 in Europe, to prevent interference between neighboring networks. This channel separation ensures that your neighbor's Wi-Fi network doesn't disrupt your connection, even though you're both using the same general frequency range. Here's an important limitation. Only one device can transmit data on a specific channel at any given moment. Other devices must wait their turn in a carefully orchestrated system that manages traffic to prevent data collisions and ensure smooth operation. Modern routers use increasingly sophisticated algorithms to manage this. Traffic efficiently, prioritizing certain types of data like video streams over less time-sensitive information like email synchronization. Once your router receives these data packets containing your video request, it doesn't simply store them. Instead, it immediately forwards your request through your internet service provider. Whether that's a major company like Comcast, Verizon, or a local regional provider, your ISP acts as the intermediary connecting your home network to the broader internet infrastructure. The ISP routes your request across vast networks of fiber optic cables, servers, and switching stations. Carry your request until it reaches the destination servers hosting the content you requested. In this case, YouTube's massive server farms. YouTube servers process your specific request, locate the video file you want to watch, and begin transmitting that data back through the same complex pathway in reverse. The video information travels as binary packets through internet infrastructure, reaches your ISP, which forwards everything to your router. Your router then transmits these packets back to your phone using those same radio waves we discussed earlier. Your phone's processor receives these scattered packets and reassembles them into their original coherent form, which becomes the video you watch on your screen. This entire journey from your initial tap to video playback beginning occurs in mere milliseconds, so fast that you perceive it as essentially instantaneous. The engineering brilliance required to make this wireless communication system reliable, fast, and secure cannot be overstated. Multiple layers of protocols, error correction, encryption, and traffic management all work simultaneously to create the seamless experience you expect every time you connect. Pretty remarkable technology when you actually understand what's happening behind that simple Wi-Fi icon on your screen. Anyway, if you found this explanation interesting or learned something new, consider subscribing for more content breaking down the technology you use daily without thinking twice about it.